Okay, guys, so I would like us to look at numerical methods for first-order differential equations. Not all the first-order differential equations may be solved by separating the variable method or by the integrating factor method or Bernoulli or the exact. So a number of other analytical methods of solving differential equations exist. However, the differential equations can be solved by such analytical methods. The number of equations that can be solved by such analytical methods is fairly restricted. Where a differential equation and some known boundary conditions are given, an appropriate solution may be obtained by applying a numerical method. So I want us to start by looking at the Euler's method. Now, the Euler's method is derived from the Taylor series. So it is given by y1 is equal to y0 plus hy prime of 0, where h is the given interval. So given a particular question like this, I want us to get the values so that you can be able to plot the solution. So obtain a numerical solution of the differential equation dy dx is equal to 3 into 1 plus x minus y, given that the initial conditions that x is equal to 1 and y is equal to 4. Y is equal to 4 for the range x is equal to 1.0 to x is equal to 2.1 with intervals of 0.2. Now, how do we go about the solution? We already have the formula for getting y1. So that's the formula we'll be using repeatedly so that we get the values of y1 all throughout. Now, solution. Guys, so in our question, we already know that dy dx is equal to, so dy dx is equal to 3 into 1 plus x minus y. Okay, with our x naught being equal to what? Our x naught is equal to 1 as given here, the initial condition. And y naught being what? Y naught is equal to 4. Okay, and y prime. So what's going to be our y prime of 0? What's our y prime of 0? Y prime is basically dy dx. Are we together? And we've been given dy dx here. So y prime, so we've been given dy dx here. Y prime naught at the initial, at the origin, what is it going to be? So we will have our y prime naught. Let me write it nicely. Y prime naught. So our dy dx is this, guys, and this is the same as y prime. It's the same as y prime, okay? So y prime naught is at x naught. Basically, you're replacing the value of x with 1. So y prime naught will be given by 3 into 1 plus, what is x naught? X naught is 1 minus y naught. Y naught is 4. So evaluating that, we get that our y prime naught is what? So that will be 2, 6. Our y prime naught is 2. So we already have these values. Okay, so we can be able to plot our table with the values of x naught, y naught, and y prime naught. These are our first values. Let me put them in circles like this so that we can be able to refer to them later as we are plotting our points. Okay, guys, so from this original equation for finding the Euler solution, y1 is equal to y naught plus h y prime of 0 or y prime naught. We can be able to continue with the same process so that we are able to find other values. So y prime is equal to y naught which is now 4. Look at what I've underlined there. 4 plus h. What's the value of our h, guys? The value of our h is given in the question, and we've been told that the interval is 0.2. So this is our h. So 0.2 multiplied with y prime naught. And y prime naught we've gotten from the initial question as y prime naught is 2. So what's our y1? What's our y1 now? Our y1 will be equal to what, guys, if you evaluate that? So this is 0.4 plus 4. Our y1 will be equal to 4.4. Our y1 will be equal to 4.4. Guys, now continuing with the same process, as you can see, we've been given that our x is 1 all the way to 2, and our interval is 0.2. So this is our x naught. So what is our x1? Our x naught is this, and the interval is 0.2. So meaning that our x1 is 1 plus 0.2. So our x1 is 1.2. Okay. Now, if our x1 is 1.2, our y1 is 4.4, then what is our y prime of 1? Our y prime of 1 will be equal to what? We know our dy dx is this. So where there's x, we are replacing now with x1, and our x1 is 1.2. So what will that give us? That is 3 into 1 plus, instead of x, we will put 1.2 minus, instead of y, we will put y1, and the value of our y1 is 4.4. 4.4. So what's the value of our y prime of 1? So our y prime of 1 will be equal to, this is 1 plus 1.2 will give us 2.2 multiplied by 3, and then minus 4.4. If you evaluate that, you'll get 4.84, guys. Okay, you'll get 4.84. Okay, then we continue with the same process, guys. So I am going to do the last one, then I want you guys to now continue all the way up to 2. Now, what is our x2, guys? What is our x2? Our x1 is 1.2 and the interval is 0.2. So our x2 will be 1.2 plus 0.2. So our x2 will be what? 1.4. So what is our y2? Our y2. So our x2 is that, and our y2 basically will be what we got here, which is 4.84. So in that case, what is our y? I'm still using this equation. So instead of y1 here now, this is y2. Or we can still call this x1, but at the end of the day, it will be more confusing. So we'd rather call it x2. So our x2 is this 1.4. If this is the value of x2, then our y2 will be whatever we got here, which is 4.84. All the same, we can still call it y1 to avoid confusion. We can still call it y1 so that we refer to all of them as y1s for uniformity's sake. So our y1 is, for x2 being 1.4, our y1 is now 4.8. Then what is our y prime of 1? Y prime of 1. Y prime of 1 will be given by this equation here. The only thing we are replacing is now the value of x and y. Are we together? So the value of x at this instance will be 1.4 and the value for y will be 4.8. So our equation is going to look like this. 3 into 1 plus, instead of x, we have 1.4 minus, instead of y, we have 4.84. And if we evaluate this, we get 2.36. So in a similar manner, we can fill up this table so that we get all the values from x naught, which is 1, all the way to the final value of x, which is 2, using the intervals 0.2. Using the intervals 0.2. Okay, so let me draw the table. Someone says y1 should be 2.2. Okay. So this is 2.2, not 2.36. Okay, so let's have the table. Let's have the value for x naught. Let's have our value for y naught. And let's have our value for y prime. So the first time evaluating, we had our x naught as 1, and we got our y naught, actually we were given as 4, and then we got this as 2. Then using 1.2, we got 4.4, and then we got 2.2. Okay, then using 1.4, oh, wait a minute, guys. This 2.2, this is 2.36. This, I think, is what is, let's see. So if you evaluate this, just evaluate it using your calculator, you see what you're getting. If you evaluate this, this is 2.36. Y prime of 1, this should give you 2.36. Y prime of 1. Okay, I didn't write the answer for this. This is what we got. We get us 2.2. So coming to the table, we have that 2.2. Then when we were using 1.4, we had this as 4.84 and then 2.36. So guys, can you continue filling the table for x values all the way up to 2? So having x value as 1.6, 1.8, 2.0. So what are we going to have for the values of y naught and y prime naught? So guys, when x naught is equal to 1.6, our y naught is what? Our y naught, clearly see, our x naught is this. So our y naught was this, the previous one. So our y naught is equal to 4.84, okay? So what is our y1? From the formula, we know that y1 is given by y naught plus h y prime naught. Are we together? So our y1 will be equal to y naught, which is 4.84, plus h, which is 0.2, multiplied by y naught prime, guys. If you replace the value of y naught with y naught prime with 2.36, y naught prime is 2.36. So 2.36. What's going to be our answer for y1 if you solve that? If you solve that, what's going to be our answer for y1? So put that into the calculator. 0.26, 2.36 plus 4.84. This should give you 5.312. So let's fill the table. For 1.6, we have our y1 as 5.312. Okay. So if that's the case, guys, Our y1 is 5.312, and our y prime of 0 at this instant is 3 into 1 plus, let's recall the formula. I hope you guys remember it. Our dy dx, 3 into 1 plus x minus y. So we have 3 into 1 plus x. Our x is 1.6. Okay. Minus our y, which is 5.312. And that gives us, if you evaluate that, you get 2.488. So let's fill the table with the values. So this is 5.312 and this side is 2.488. Okay, guys, let's do the same for 1.8 now. For 1.8, I want you guys to see x naught is equal to 1.8. Okay. So if x naught is equal to 1.8, what's going to be my y1, guys? Y1 is equal to y naught plus h y prime naught. What's my y naught? Go back to the table and see what the value of the y naught is. So for 1.8, y naught is 5.3. 1.8, y naught is 5.312. So we have this as 5.312 plus the interval is 0.2 multiplied by y prime of 0. Our y prime of 0 for the previous is 2.488. So when you evaluate that, what do you get as your value of y1? What do you get as your value of y1, guys? You should be able to evaluate this and get 5.8096. Okay, then what is our y prime of 0 for that? What's our y prime naught? So our y prime naught from the formula dy dx is equal to 3 into 1 plus x. Our x naught in this case is 1.8 minus our y naught in this case is 5.8096. And what does that give if you evaluate? So if you evaluate this, you get 2.5904. Guys, do the last one for x naught is equal to now 2. So filling this table, we have at 1.8, we're going to have 5.8096. And this other value is 2.5904. 2.5904. Get for me this value, guys. What is this going to be if you use 2? For the sake of time, let me just get it. So for x naught being equal to 2, guys, our y1 from the formula is y naught plus h y prime 0. So what is our y naught? If you check the table, our y naught is 5.8096 plus h, which is 0.2, multiplied by y prime of 0, which is 2.5904 from the table. And this will give us 6.327. 6.3276768. That's what we're going to get. So we can fill that in the table. We can fill that in the table. So guys, since we were given, we want to plot the solution of the graph and the range was from 1 to 2 values of x. So this is what we are going to have. We have values of y on this side, we have values of x on this side, and the values of x are running all the way from, x is equal to 1 to x is equal to 2, with intervals of, you know, the intervals are 0.2. So I have 1.2 here, 1.4, and so on. I want you guys to plot for me this graph. The initial condition, tuliambiwa y naught is 4. So we have 4 here. Then I can just have this 5, 6. We're having all the way up to 6.3. Okay, so let's have that. Can have maybe 7 there. So I want you guys to plot value of x against value of y. So at x naught, we have y naught here. Yeah. At 1.2, what was the value? If you go back to the table, you will get that at 1.2, our value was 4.4. Okay. At 1.4, our value was 4.84. At 1.6, our value was 5.3. And finally at 2, the last one, our value was 6.3. So guys, plot those and then let's see what kind of a curve we get here. When you come back, we see what kind of a curve you have here. We come back in 10 minutes time. I've shared 2 links. So the next link is for the next meeting. Okay, see you guys in 10 minutes time.